So I want to thank you for inviting me here today. It's not often a dentist gets to play away from home like this. It's fantastic. But I really feel quite at home because I'm with makers. That's brilliant because really, that's what I am. I think that's what all dentists are, possibly all surgeons. And that's my daughter, and that really shouldn't be there, but she's lovely, isn't she? Let's try again. We made her. So, let's try again. I am a maker. I am a maker, like all surgeons. And what I'm really talking to you about today is making things, really useful things for people, for people's mouths in surgery. And the amazing thing is that even though 3D printing has really kind of just become a bit of a buzzword in the last few years, we've been doing this for a long, long time. And why dentistry? What's so special about dentistry that it brings me here today? Well, one of the things is that we have a vast amount of data, 3D data that we can capture from our patients. We have CT scanner data, we have intraoral scanners, I'll show you one in a moment. We have model scanners, so we can capture information from our patients. And in my case, I can send that to computer-aided design, computer-aided designers, and our industrial 3D printing to do all kinds of interesting things. Some of you in the audience will have had your mouths filled with gunge and an impression taken, a mold made of your mouths. This is going to change everything for dentistry. This is an intraoral scanner that captures thousands of images to put together, to assemble a 3D model so that these guys can work on it. Because there's no point in having all this technology without people who understand how to use it, without people who can take that data and interact with it. 3D printing is about building things one layer at a time. And civilizations have been doing that for thousands of years. So, one layer at a time, we can create intricate brick structures as long as we support them along the way. And we can form objects one layer at a time if they're able to stand up on their own. But why dentistry? Why is it that 3D printing is so applicable to dentistry? Well, it's because every one of you and every one of your teeth is different. And every time we touch that tooth, every time we pick up an instrument, we change it. So everything we make for our patients is not only bespoke, but also very complex, very geometrically complex. So this is one of the first patients I looked after where 3D printing changed everything. Because this is a chap who had a cleft lip and palate, most of the front of his jaw was missing, and he was told that no one could do anything for him. We were able to model his jaw using the kind of fairly crude 3D printers that were available at the time. And by studying it, by paying careful attention to the defect, by actually trying out surgery, we were able to carry out dental implant treatments and reconstruct the jaw and bring him back to a far better quality of life than he experienced before. I'm very lucky because not only do I work as a dentist, but I also work with Veronique and Jonathan, who run an imaging business for medical imaging, dental imaging, and Jonathan, who's an architect and runs a 3D printing and 3D modeling business. So working together, we can do some extraordinary things. So we 3D print and make craniofacial implants. We make prostheses, which can be used for patients who have missing teeth, mundane things like that. but we also work with some brilliant and inspirational artists, helping to realize their ideas. And I really believe that working with those artists changes everything for us, because they truly inspire us to do more with our technology. But 3D printing allows us to do so much for our patients. We can make and model, we can make implants, make the kind of models that dental restorations sit on. That sounds terribly mundane and boring. They used to be made from plaster of Paris. Now they're 3D printed. We can make the kind of metal structures that later get covered with porcelain. We can make ceramic frameworks, and we can make cutting guides and drill guides that allow us to pre-plan our surgery and carry it out with precision. For us, 3D printing is so familiar because the materials that are used in 3D printing are actually materials that are commonly found in dentistry. So we're makers making things using this technology that actually we made previously using ordinary artisan technologies. So we can make using light cured resins, using lasers to fuse powdered metals to make metal structures, and using heat and lasers to make resin structures. I mean, this is what we used to do. We used to use the lost wax technique, which has been around 5,000 years. This is how people made jewelry. This is how people make jewelry. And it's probably how many of your dentists make things like gold crowns and porcelain restorations. But this is all changing because now we are using 3D printing where before we used plaster of Paris. We're using 3D printing and 3D milled ceramics where before someone had to carefully structure the whole thing using difficult artisan processes in a basement somewhere. Now we can concern ourselves with the detailed aesthetics on the surface of what we make in this context. And when we make things in metal, we're fusing powders together, and we can make things in large varieties of metals, biocompatible metals like titanium, metals that we can fuse porcelain to like cobalt chrome. So we can make a lot of things with 3D printing, and we do. But we can also use 3D printing to transfer information from a software plan to a surgical site. And if we look at one very mundane example, this is a patient who's missing a front tooth. They're going to have an implant placed. We can plan it in our 3D data, and we can construct on-screen models of the teeth, the jaws, the bone, the implant as it's going to be placed. We can plan a sleeve that's going to allow us to position the implant very accurately in relation to a tooth. And then we can actually 3D print a guide that's going to guide us in the right direction. And you know something else? We can make the tooth that we're going to fit even before we start. So we can go to our patient with a surgical guide. We can drill precisely in a planned position. And actually what we can do is at the same time, in just a few minutes, we can position a restoration. So we can go from gap to tooth almost instantaneously. This is what used to take months, done in minutes. Okay, that's a straightforward example, and we've seen how makers can change the way things are done. And I want to look at an example of the dentist turned maker, because this is now about saying how can we make treatment easier, faster, less invasive for a patient. This lady had cancer of her jaw. She's going to lose most of the front of her jaw. Large tumour. And the way that this is dealt with nowadays very often, because we're not growing bone yet, we're not 3D printing bone yet, we will one day, is to take bone from another part of the body. So this is the jaw structure. We can see what's going to be taken away, and we can very simply and crudely measure what needs to be replaced. And how are we going to replace that missing structure? Well, what we're going to do is look elsewhere in the body, and this is a common process, a microvascular free flap, where we're taking bone from the fibula and transforming it into a new jaw form. And what you see there is a 3D print of the patient's fibula and a 3D print of a prototype guide so that we can think about how we can transform this fibula into a functioning jaw. Now, it's before lunch, and this is a bit of a nasty picture, so if you're a little squeamish, please just look away for a moment. So this is the patient, and the front part of the jaw is being resected. And this is what we need to replace. And here we have made and prototyped and 3D printed a guide that's fitted onto the leg. Dental implants are being placed through the guide into the leg that's going to become the jaw. And the next step then is to lift this bone along with the blood vessels that carry nutrients to it, and to adapt it using a 3D printed cutting guide and form it and shape it to a jaw shape so that we can plumb this into the vessels of the neck, connect it up, and actually go straight to function. So what does this mean? Once upon a time, that patient would have left the operating room with nothing there. Cancer fixed, but nothing there. And you can imagine the effect that that has on the quality of life of the patient. You can imagine the effect that that will have on the healthcare system. But using this sort of technology, we can be more accurate. We can return our patient to society faster. But there are hurdles that need to be overcome. And actually, that's one of the things that makes me so excited to be here, to talk to people who maybe can make this happen faster in our hospitals and in our NHS and in dentistry. This was said about lasers. The solution, looking for problems, well, one of the problems that lasers helped us with was 3D printing, because of course they've been hugely instrumental there. But I also think that 3D printers are a solution looking for problems, because there's so many things that we will be able to do in the future because of 3D printing. So finally, an important case, a very important case, because Josh, the patient, has been brilliant enough to come along today to speak to us. Now, Josh suffered from a melanoma of his eye, which led to the loss of the left side of his jaw. And again, with so much missing structure, we had to look for a radical surgical solution. And this was what we achieved with a graft of bone taken from the scapula, that surgery carried out by Professor Ian Hutchison. And I placed dental implants into this graft. And how do we go about this sort of treatment? Well, by 3D printing the skull, by 3D printing the problem, the state, it's so much easier to find a solution, to tangibly hold in our hands an object that we can get so much information from before we go into surgery to make surgery quicker and easier, so that we could go from a virtual pan to an actual reality quickly, less invasively, providing teeth very soon after this procedure. So this is the result that we achieved. And actually, as I hope Josh will explain to you now, perhaps this was just the start of the journey. And I want to ask you to welcome Josh.
Good afternoon, everybody. It's a pleasure to be here just to talk you a little bit through my journey. As Andrew will have already told you, I lost quite a bit of my face due to malignant melanoma. I have to say every cloud has a silver lining, and I was very fortunate to have a wonderful team of surgeons who worked together on me. But also throughout the process, I was very fortunate that I discovered something very new. My skull in 3D. I found this quite amazing, to be actually able to hold something that was inside my head. Really amazing. So, hang on, I hope I'm getting this the right way. I graduated from the Royal College of Art back in the last century. It was actually 1990. And back in the day, we used a pencil and paper for designing. It's quite remarkable to think how much things have changed over the last, quarter of a century, really. In the last few years, I've been using Adobe Illustrator for my design work. This is amazing, especially for prints. Here are some prints I designed just after I'd had my eye removed. Obviously, eyes were a lot on my mind, and Moorfields Eye Hospital, their emblem was the peacock feather, so I combined the two to form some print designs. Seeing this gave me the idea that perhaps I could introduce this method into my design process. So, having done lots of print designs, I thought it would be really nice to come up with something that would be practical and useful. So I looked around my house, just took everyday objects. Obviously a bottle opener, which is very useful in my house. I live in a 1930s house, so there were 1930s doorknobs and bottle decanter stoppers. So I took these objects, and I was very fortunate to be able to work together with digits to widgets. And I came up with this concept of just taking everyday objects but transforming their use and producing something else. Here are some of the prints I've designed and the first imagination of the handles and how they would look. So here we have the corkscrew with photogrammetry, which is amazing. It just takes lots and lots of photos. And in the end, oh, hang on, I'm going too fast here. You end up with this, and then it was smoothed off, and you end up with something like that, which was then adapted with a screw-in end and an area so that you could keep the spokes of the umbrella. Yeah, here's just a few of the umbrella handles that we've managed to do the prototypes of. There's actually my hand in amongst that lot as well. So you've got the idea of hand in hand. So here you see just a little group of the handles put together, the prototype images, and yet again that's another image showing yet a different decanter stopper. And here finally is just taking printing, doing the printed version but coating it in a metallic finish to give another image. So to be honest, I've just taken everyday, very simple objects, but I've recreated them to give a new look and something that I think is quite commercial. And yeah, that's just me holding my skull and stating the obvious there. Yeah, I'd like to thank you all for your attention.
This wouldn't be possible without brilliant patients, and it also wouldn't be possible without forward-thinking surgeons who are prepared to face these challenges. And so my presentation wouldn't be complete without also mentioning Professor Ian Hutchison and Mr. David Verity, who actually looked after Josh, and also Mr. Nicholas Calabresos, who has been very involved with some of this work. So thank you all for your attention today.